Hey guys, this is the second part of our OOP fundamentals topic. Let's see what we got. So you guys remember that object-oriented paradigm has four fundamental or core concepts, and we learn them by this abbreviation, a PI. So abstraction, polymorphism, inheritance, and encapsulation. And we have already covered the abstraction and inheritance, right? And today we're going to talk about the encapsulation. Also, uh, after the encapsulation, I'm going to introduce a very important structure that we call it interface. So this is different than the interface that we have been using. Encapsulation. What is encapsulation? Let's look at encapsulation concept first from the etymology point of view and see what the dictionaries talk about that. So encapsulation here in as usual I use the Merriam-Webster. So to completely cover something, especially so that it will not touch anything else. So it is saying that we want to cover something. So let's say we have something like this, we cover it in such a way that won't be touched by anything else. So if I want to explain it in plain English, it means that we put something in a capsule. That's why we call it encapsulation, right? So we put something in a capsule and isolate it from its outside world to touch it, right? So yeah, that's the definition that we are looking for in the computer science for encapsulation. So we define encapsulation in OOP as this. So it is an ability like other concept that we have learned, in OOP fundamentals. You know, these fundamentals gives us some ability, and encapsulation is one of them. So the ability to bundle attributes and behaviors. So bundle here is the same as putting something in capsule, right? So we have the ability to bundle attributes, behavior, and we know that where it's in class, right? And controlling their visibility. All right. So we put everything in a class, we bundle everything in a class, and we have full power to control their visibility. And what is this there here? This there, it can be attribute, can be behavior, and it can be also the class itself. We have the ability to control the visibility of the class as well. Okay. So, in other words, maybe we can say encapsulations give a power of controlling how the class looks like from the outside, right? And we know what it is, yeah? You know that if this is a class, and when you look at this, what you can see from this object is the API or is the interface, right? We talked about this before, but now we are giving a name to that. So these things, putting everything inside a capsule and controlling its visibility, now it is called encapsulation in OOP, terminology. Okay, and also when we can do this, when we can control the the visibility, also we can, based on this controlling visibility, we can change the access level of attributes. What does it mean? We can change the access level of attributes. Let me explain that in the in detail in the next slide. But to just to summarize that what is this access level, it means that we are talking about the attributes. We can make the attributes read only, or write only, or read write, or even none. And in this case, we just hide the attributes, right? Okay, so let's see how can we do that. Before, in the previous courses, you have learned what is the getter, what is the setters. We are talking about in Java terminology. All right. So getters and setters, also known as accessors and mutators. So getter is accessor and setter is mutator, right? And both of these can applicable for the instance variables. The question is, how can we do that? How can we make a instance variable read only, write only, read, write, or none? It's very easy. If we just provide the getter, then the attribute will be considered as a read only because we don't have, we cannot change it. So it is just a read only thing. And if we just give the setters, then that attribute will be write only. If we provide both of them, the attribute will be read write. And if we don't provide anything, the attribute will be invisible. In this case, in this way, we can hide the attribute from being used by the user. So in this case, internally, it will be used by the methods. Okay, so now let's see what we get. What is the benefit of this encapsulation? So since we can bundle everything, it means that we can put all of the related functionalities in one place. This is, this is wonderful ability, right? In this case, we have the ability to organize our code. Okay. And since we can control the visibility, we have this ability to give the users of our class the thing that they should need to know, nothing more. So this ability is important. For example, in the previous slides, I talked about how can we control the access level, right? So read only, write only, or read, write, and hidden. So in this case, we just give the necessary access level to the users, right? So this is actually a protective barrier that we have to control that the users accidentally change something and mess up everything. All right. Okay, so now let me give you some notes about the encapsulation. In some articles and some books, you might see they call encapsulation as data hiding or information hiding. So they use these two things instead of encapsulation, which is totally wrong. So wrong. Why it is wrong? Because what was the encapsulation? Encapsulation, has two ability. First, bundling thing. Yeah, you can bundle information and behavior, or attributes and behavior. Attribute and information are the same here. And also you have the ability to control their visibility. So yeah, so we can control it. So if we just say that encapsulation is equivalent to data hiding, it's not fair. It's not the all of the things that we can do. All right. So and also where is the bundling ability here? So when we say data hiding, we missed the bundling thing here. So I totally disagree with these two, uh, idiom or whatever terms being used instead of encapsulation. Okay, so this is a definition of mutable object. When we can say an object is mutable, when we can change the attributes, all right, or we can change the state of the object. You know that the combination of the values of the attributes, that combination of them is called the state of the object. So if the state of object can be changed, then we call that class as mutable. All right. That's why we call the setters as mutators. Okay. We will get back to this mutability and this kind of thing later in detail. All right. That's what we have for encapsulation. What is interface? So interface, the the concept of interface that so far we have learned was whatever is exposed to the outside of a class or a object, right? So here I just summarize it with a set of visible members of the class like this. So this is whatever we used so far. All right. Okay, so when we have a class, we can pull out the interface of a class and put it in a separate file. This is, the ability we have. Let me take a practical example here. So let's say we have a class called dog. Okay, look at this dog. So this guy is private. So let's call it as voice of the dog. It's a private, so it's not part of the interface. We have a method here which is public. Yes, this is part of the interface. Okay, so we can pull out this interface, this part, because the implementation, we don't care about the implementation, but we can pull out this part and put it in a separate file, and we call it interface. So how can we do that? So very easy. So look at this. So we create public interface and we name it something. Here I named it as dog int. This int means interface, and I just put the signature of the this method here and semicolon. No implementation of the method. So what we said? So we said we can pull out the interface of a class and put it in separate class. I'm sorry, separate file. And here how we can do that. But we need to talk more about this, right? So now let me give you some notes that how it works. So first of all, you saw that we use the keyword interface like this, public interface, and we gave a name to our interface. All right. And we noticed that we don't need to implement or to put the implementation of the method in the interface file because interface is interface. We are looking for the interface, and the interface of that method is its signature. Okay. Usually we add some prefix or suffix, like the int that I gave to this guy as a dog int, or even I. We can put the int at the end, or we can put at the beginning, or I, to be able to distinguish that this is an interface, not a class. All right. Um, yeah, this is just as a convention. It's not you know, consensus way of doing this. Just this is just a convention. So we named dog int in our previous slide, but this is not the way that we do in practice. In practice, when we create an interface, that interface should have a higher level abstraction name. What does it mean? It means that for this particular example, probably the best name for the interface would be animal int, which is a higher level abstraction. So dog is a very specific animal, right? But when we create interfaces in practice, usually the name of that interface, it should be in higher level abstraction level, like this example. Okay, so whatever we did so far is not really what we do in practice. We had a class and then we pulled out the interface of that class and put it in a file, right? And I want to say that this is not whatever we do in the practice. In the practice, it is totally the other way around. What does it mean? It means that we first we create the interface and then we create the classes. All right, and this is the desired thing for the designers. The designers usually define the interfaces first. Why? Because class is a very specific thing, and it is specific to implementation phase, right? So designers don't care about the implementation. They just need some names, some names that can describe in an abstract level the behavior of the application. That's why they like to create the interfaces. Okay, so so far we learned that the application of the interface is, first of all, they are uh, in a higher level abstraction of whatever the application want to do. And also we learn that designers like the interfaces because interfaces are is a very general thing. It's a very general template, and it's not related to any specific classes. Okay, so let me take an example to clarify everything here. So animal interface. So first, it will be created by the designer or even the developer. It depends on the project, depends on many things, right? So first we create the interface like this, and we put what the desired uh, methods and all of the uh, members that should be visible to the users of the class, we put them here, right? So, and then what would happen when we are talking about a specific class, let's call it dog, and dog want to follow this template, then we say, okay, when we are creating the dog, we would say, yeah, its public class, its name is dog, but it implements the animal int. So in here, we are specifying that this dog class is following what template. So this animal int is the template that this class is following. All right. Okay. So when we do this, what would happen? When we do this, what would happen? Then compiler, Java compiler, and in this case, just when you are using Eclipse, let's say, when you say implements animal int, then the Eclipse will expect that you need to implement this method. And if you don't, then it will uh, complain. Yeah, let me show you in a live demo. Okay, let me bring up my Eclipse here. All right, let me create a new package for all of our demos here. So uh, let's call it encapsulation. And inside this encapsulation, I create an interface. Uh, we call it animal int. Okay. And inside this interface, we would rather to have a public void print voice, something like this. Yeah, that's correct. Okay, and let's save that. And also we need to have a concrete class, and we call it dog. We can specify the interfaces that dog is gonna implement here, but I would like to show you, uh, manually how we can do that. So dog implements animal int. Okay, and now there is a complaint here. You see, what is this complaint about? It is saying that the type dog must implement the inherited abstract method animal int print voice. It is complaining that if you are going to, let me make it side by side like this. All right. So it is saying that if you're gonna implement an interface, you need to implement all of the methods. That's the reason of the complaint. So we need to implement like this. So for example, void print voice. It should have exactly the same signature. Note that. So yeah, we should put something here. Let me just give some um, fake things. Just println, let's say wolf. Yeah, something like this. Now the complaint has gone. Okay, so this is whatever we do in practice. We create the interface, and then we implement that interface inside our class. And in this way, we are sure that we are following this template. And you will see later that how important is this. Now let me mention some notes about the interface. As we said, we use the implements keyword to implement an interface inside the dog class, right? And we notice that if we don't implement all of the methods that are mentioned in the interface, then the code won't be compiled. So And also this is the important one, that when we implement an interface, the relationship between the interface and the class that implemented it is an is a relationship. So dog is an animal, right? Okay, so this very important thing. So it looks like an inheritance things. Both of them are is a relationship. Now that we have a new relationship between an interface and a class, so we need to talk about the UML diagrams. Okay, so we learned before that we have 6 relationships. And these are the relationship that we mentioned before, right? And we all, already covered the first 4, and now it's time to talk about the interface implementation relationship. Okay, so we learned that every relationship has its own connector, and these are the connectors we have learned. So for the implementation, we will have this guy. It looks like the inheritance, you see, inheritance, but it is solid line. This guy is a dashed line. Let me take an example to show you in practice. So dog implements animal int interface. And we learned that dog is an animal int. All right. So we show this relationship like this. So this is our interface, and this is our class, and this shows that there is an implementation. Okay. The arrow tips exactly like the inheritance is pointing to in inheritance it was pointing to the superclass. Here it is pointing to the interface. Okay, so to distinguish between the class and interface, even though we use the name, but in the UML class diagrams, we use these 2 guys here, the two, let's call it delimiter or whatever. So this is a French symbol that is called guillemot, and we distinguish when we have this, we distinguish between the class and interface. Let's see quickly how we can draw this relationship in the violet. This is the violet. So we go to the class diagram. So you see we have a specific toolbar for this. So this interface. All right, and you see that those 2 guillemets are there. So yeah, we should go ahead and yeah, be careful about don't delete that guillemets. So animal int, right? And then we can create a class here. Let's call it dog. All right. And now we use this implementation of the interface, and we implement that like this. So far, we talked about 5 relationships between the classes, and the last one was between a interface and a class. So the sixth one, the sixth relationship is called association. Let's see what is association. In some cases, some designers don't like to mention the aggregation, composition, or dependency because they think that these kind of things are very implementation specific. So in that case, they use a more general relationship that is called association. So what does it mean? It means that instead of using these two and this guy, the dependency, they just use a very simple and generic or general purpose relationship, which is called association. So if we say association, we mean what? It is either aggregation or composition or dependency. All right. In this course, we won't use this. I am just mentioning this because, to make a complete discussion about these UML things, right? But we are not gonna use this association. But let me at least explain very briefly that what it is. So these five is, has been covered, and the association is either a solid line like this, or it can be also uh, an arrow here, or this way, or even that way, right? Or even both sides. So I just use the solid line here, but just keep in your mind that it is possible to have an arrow in both sides, one or both sides as well. So the connector looks like this, and class A and class B association relationship is being shown by this solid line. And also uh, know that it we can put some role here, that what is this class A is for and what is this class B for, right? So we can put some roles here. All right. So let me take an example. What does it mean by the roles? For example, so the course class and student class, right? And we didn't use that, that uh, aggregation composition, and we are just using the association like this. So the role that designer like to write is, what is the role for, what is the role of students for course class. So it means that a student registers for the course. So here we put the role of the, what the student has to do for the course class. And what is the role of the course for the students? In this case, we would say course has students as participants. And if we would like, we can even mention the multiplicity if the relationship is actually aggregation or composition behind the scene. All right, we can mention the multiplicity here and here. All right. Uh, okay. Now let's get back to our ingredients of the interface. So interface uh, can have, as we said, unimplemented methods, right? So what is the type of these unimplemented methods? They should be, if they are unimplemented, then they should be abstract methods. Or in other words, they actually are public abstract methods, right? So you have two options. Either you mention that the method is public abstract, or you can omit that because, by default, all of the unimplemented methods of an interface are by default public and abstract. In our previous example, you look at this public void print voice. Yeah, we were talking about this. So you can say it is public and abstract, no problem. And it is abstract because there is no implementation here. And also you might omit all of this because, by default, all of the methods like this would be public and abstract. Since Java 8, there might be some implemented methods as well, but those methods should be qualified by the keyword default. So this default should be part of the name of the method. Okay, what does it mean? For example, let me create another uh, method here. We would say default, and let's say void uh, print hello, just for demo, and just print hello here. So what's happening here? We created a implemented method, right? And we are saying that, and you see there is no complaint here because it's an implemented method and it will be inherited here in the dog class. Uh, Our next point or note here is that interfaces can have constants, and constants are qualified by the public final and the static, something like that. Okay, so you can omit these three keywords because by default, if you create a constant, it should be public, final, and static. Let me see. Okay, here, for example, this is our interface. So public, static, final. Uh, just as a very quick example, there's just a name, and this is just my name, you see. So this is a constant, and this constant can be used here, right? So for example, we can uh, have this guy, and we can call that constant by the animal int, and you see the constant is available, and we we can access to the constant by using the name of this interface. And if this is a class, the same way, yeah, we need to use the class or interface name and then dot, and then using that constant. And the constant is public, is static, final. And if we remove that, nothing would happen because by default, all of the constants are public, static, and final. So our next note would be interfaces can have static method, all right? And also uh, interfaces can only be public and abstract, that we talked about that before. And also interfaces cannot have instance variables, all right? So these are the ingredients of the interfaces. Okay, now let me take an example from the Java library. So in Java library, list is an interface, all right? And and also you are familiar with the array list, right? Array list and linked list, right? And both of these two guys implements the list, all right? Because they have some common things. That's why both of them are implementing the list. And here is the class diagram of these three guys. So list, array list, and linked list. All right, let me give you some more notes about the interfaces. So, as we will see later, interfaces in object-oriented programming has a great role. They are so important. And during the semester, I'm going to talk about this a lot. All right. So interfaces, as we said, they are some kind of abstraction. It means that they will tell us what should be done. But since the implementation is not important in interface, it means that not how to do that things. It just say that what should be done. Okay. Another thing is you can implement as many as interface that it is required. Okay. Let me bring up my for example, here we just implemented from the animal int. Yeah, you can implement from other interfaces as well. For example, let's say, for example, from the Java list, right? And of course, we would need to import that here, right? And you can continue and implement from other things. So as many as that you need. All right. We have been using the keyword interface for two different purposes so far. They are somehow related to each other, but you need to be able to distinguish between these two from the context of the this course. So at the beginning of the semester, we started using the interface as a general term that was equivalent to the API, and now we are using that as a Java language keyword for a structure. It's a construct. It's a Java construct. It's a file. It's a separate thing, right? So you need to be able to distinguish that when we are talking about interface, we are talking about the API or we are talking about the that construct, the Java construct that is called interface. So inside the interfaces, each interface can extend other interfaces as many as it needs, right? That's another very interesting thing. So an interface can extend any number of other interfaces. And for extending, we use the same keyword as extend that we use for inheritance, right? But the difference between the interfaces that extend other interfaces and classes that extend other classes, classes just can extend one class. But in the interface case, they can extend as many as required. All right, that's the very important uh, difference between this extending thing. Let me quickly show you a demo about this, how an interface can extend other interfaces. Okay, so for simplicity, I just created some simple interfaces here in this file. So let's say, for example, interface species, right? Yeah, you can add more stuff here. Another interface here, let's call it, for example, creatures. Yeah. So now we have two other interfaces, and we can go ahead and here and say, okay, so animal int is going to extend the species and also creature. You see, you can add as many as interfaces that you would like. All right. That's what I have for today, and see you guys in the next lecture.